Hi, everybody. So in this video, I want to continue talking about different measurements of the shape of data, mean, median, and we're going to mix in a new one today, which is standard deviation. And so rather than get into the details about the formulas and how we calculate these things, I want to attack this more from an intuition. How can we just look at histograms and kind of get an informal idea of what the mean, median, standard deviation might be? So here we've got three different histograms up top. And we would call all three of these histograms, if we were to describe their shape, we can describe them as symmetric. And so what that means is if we drew a line down the middle, what's on one side, it looks like a mirror reflection of the other side. And that's true for all three of these histograms. And in each of these situations, when we're comparing measurements of center, there actually is no difference between the mean and the median. So when shape of data, when our histogram is symmetric, this is going to tell us that the mean is going to equal the same as the median. When we have data which is what we would say skewed, when it's not symmetric, so when we have outliers in our data set, so in this histogram over here, we have a bunch of outliers over here. So most of our values are stacked between 10 and 13, but then we have some small values over here. So we would call this feature of a histogram a tail. And because this is on the left side of the histogram, we would say this histogram has a tail to the left. And when that happens, remember the mean gets affected by outliers, whereas the median does not. So these outliers on the small end are going to pull the mean down below the median. So the mean is going to be smaller than the median when we have a tail, when we have outliers to the left. And looking at the flip side of that, these last two histograms, they have tails to the right, meaning most of the values are here on the left side, but there are some extreme values over towards the right, this being an even more extreme tail than the previous one. So in these cases, we have large valued outliers. And so these big outliers, remember, are going to affect the mean. They're going to influence the mean and pull the mean to be larger than the median. They're not going to have as big of an effect, if any, on the median. So we can look at data, and even without doing the calculations or having the full data set available, we can still make some approximations about the comparison between means and medians. So here are three symmetric data sets, the same three that were just on the previous slide. And so all three of these histograms, they look different, right? They're not identical to each other. But they all have a mean of 10. And since they're all symmetric, the median here is also 10. So just describing data with measurements of center, mean, and median is not really a complete picture of describing what the data looks like. So we need more metrics, more quantifiers for the shape of our data. And so these three histograms are different because this one is much more compact. It only goes between, say, 6 and 14, whereas this one is much more spread out. So it has less stuff in the middle, but more values on the extremes. So let's define one way of measuring how spread out our values are using what's called the standard deviation.